Okay, so for the second video on chapter 4, we're looking at section 4.3. And this really is something which we're familiar with half of it from GCSE, which is these reciprocal graphs. So if we have a reciprocal graph y equals k over x, then it's this shape. Now, you might want to fast forward a bit if you're confident with that shape, but for those people that want a quick recap, this is where that shape comes from. So let's imagine y equals 1 divided by x. Then if x is, if x is 1, then y equals 1, right? 1 divided by 1 is 1. So we get 1 and 1. Now, if x is bigger than 1, so say x is 2, well, if x is 2, y equals a half. And if x is 3, y equals a third. And if x is 4, y equals a quarter. So I get this sort of shape. Now, as x gets bigger, y gets closer and closer to 0, but it never actually gets to 0. If x is a million, y is a millionth. If x is a trillion, y is 1 trillionth. So I get smaller and smaller and smaller. I get closer and closer to the x-axis without ever actually touching it. And the word for that is asymptotic. And the x-axis is called the asymptote. Okay, so asymptotic being the adjective and asymptote being the noun. Now then, if x is smaller than 1, well, if x is a half, y equals 2. If x is a third, y equals 3. So can you see the symmetry there? There's a symmetry around this diagonal line here, around the line y equals x. And we get that. Over here, we repeat the same thing with minus signs in front of it. So that's where we get there. When x equals 0, there is no definition of 1 divided by 0, so we just don't get a value there. So there's a discontinuity. The graph leaps from minus infinity back to positive infinity. And we're hopefully fairly used to that. At least we've seen that shape before at GCSE. And if we times it by k, so if you got 2 over x, you still end up with the same sort of shape, roughly speaking. Okay, the graph's a bit sort of steeper, and I'm not going to discuss that any further really because we're going to think of it as a graph transformation, and graph transformations come in the next part of this chapter. So y equals 2 over x is just taking the 1 over x graph and stretching it by a factor of 2 in the y direction. And you'll be, if you're not comfortable with that, well, we're going to recap it soon anyway. If I put a minus sign in front of that and I get y equals minus 1 over x, then it does a reflection, but again, we're not going to worry about that because either you remember it or we'll recap it in section, I think it's 4.5 or something like that. So that's these two. Now, the thing you might not have seen on GCSE is where we have a squared on the top and the bottom. Well, in this case, so the example they're giving us in the book is y equals 2 over x squared. Well, in that case, you can think of it as y equals square root of 2 over x all squared. Okay, so I've squared a graph that looks like y equals a over x. If I square that, then the a squared is still just going to be a constant, right? So we can think of it like this, if you like. Okay, y equals b over x squared. The point I'm trying to make is we're not going to worry about the top not being squared. We're just going to think of it as we're taking the y equals x, 1 over x graph, or the y equals a over x graph, and we're squaring the whole thing. We're not going to worry about the fact that it looks like we squared the bottom and not the top. We have squared the top and the bottom. It's just that instead of having 2 over x squared, we've got root 2 over x all squared. Fine, root 2 and 2 are still just numbers, right? So what does it look like if we've got a number divided by x squared? Well, this part of the graph here, it still gets this shape, doesn't it? Because if you square something, well, things which are less than 1 are going to get smaller. Things that are bigger than 1 are going to get larger, but still you can see this shape, right? So when x equals 1, y equals 1. 1 divided by 1 squared is 1 divided by 1, which is 1. When x is a half, y is a quarter. When x is a third, if this is y equals 1 over x squared. When x is 3, y equals a ninth. When x is 4, y equals 1 over, 1 over 16, and so on. And then when we get to x equals a half, well, y equals 4, and so on. You can see the shape is still going to be like this. We're still going to have the asymptotes. So just looking at it, we can't necessarily see it. If we drew both of these on the same set of axes, you will be able to see it clearly. And I'd encourage you to get your calculator or whatever other software you prefer that will quickly get you a graph and just check that so you can see the two things next to each other and see what they look like. Now, with x being negative, the effect of it being down here below the x-axis is cancelled out by the fact we're squaring it. So we end up with the squared bit flips up here because, the negative x bit flips up here because x is squared, right? So it's 2 over x squared. So 1 over x would be a negative number, 1 over x and square it would now be a positive number again. And if it is something like y equals minus 5 over x, we're going to think about that as y equals minus 5 over x squared, like that, okay? And that's why the minus sign gives us a flip in the x-axis. It's another graph transformation thing. So again, either you understand where that comes from because you remember it from GCSE, or you've forgotten, in which case we'll see it in section 4.5. Section 4.4, and I'm just going to squeeze this in here as well because the two sort of short sections, not necessarily easy sections, but short in terms of what I need to explain to you. Points of intersection. Now, if you're in one of my classes, you will, by the time we get to this point, you will have this ready on the tip of your tongue. If you want to know where two graphs cross, take the equations and solve them simultaneously, okay? And in chapter 3, I've explained why I don't like the idea of put one equal to the other and how there are problems with that way of thinking about it. If you're interested, then go back and look in chapter 3 on simultaneous equations. But what we're doing is taking this and this. If we want to know where the graph for this is the graph for this, we're going to take that as equation 1, we're going to take that as equation 2, and we're going to solve simultaneously. Now, substituting in for y from this equation into this equation means that we do put this equal to that, but well, if I teach you, or if you've watched the chapter 3 videos, you'll know my problems. I won't repeat myself here. Now, we've been using that technique since we had one quadratic graph and one straight line graph. It still works perfectly well, and again, I don't want to repeat myself. The reasons I gave in chapter 3 are still valid here, okay? The points that solve this equation are on the curve for that equation. The points that solve this equation are on the curve for that equation. And so if you want points that solve both of them, you need points that are on both curves, i.e. the crossing points. So there isn't actually any new maths in section 4.4. But when you get further into this course, you'll get used to the idea that the sections where your teacher's saying, well, there's nothing new here, there's no new ideas, we're just putting together old ideas, often those are the questions where you have the hardest questions. Because putting together 4 or 5 different ideas from different parts of the book and expecting you to be able to do them all gets tricky. Now, my advice to you would be, if you're getting stuck on this kind of a section, don't just stay on exercise 4D. Go back and look at chapter 3, look through chapter 4, make sure you understand all the ideas and all the little bits in place, and then try and stick them all together in exercise 4D. So that's everything we have to say on the first half of chapter 4, where we're looking at new kinds of functions. And that leaves us with the last bit, which is on transformations of graphs, which I will do in the next video.